Hello everyone, in this video I'll be explaining the bit manipulation instructions of the 8051 instruction set. Okay. So these instructions are used to perform on bits. See the name bit manipulation instruction. The name itself is telling that these instructions are used to perform on bits. So there are total 17 instructions are available to perform the bit operations, like we have clear, set bit, CPL, and few logical operation instructions, and few instructions to check the particular bit whether the carry flag is set or not, or particular bit is set or not. And one more thing that here, please note that the direct addressing mode is used in operating the bit manipulation instructions. So before discussing the bit manipulation instructions, we briefly will go through the architecture of the internal RAM memory location, right? So here 128 bytes of RAM is divided into three sections. That is from 00H to 1F8 is allocated for the register bank, and from 30H to 7F8 is allocated for the general purpose RAM, and from 20H to 2F8 is allocated for the bit addressable location, right? So here from 00H to 1FH, it is a byte addressable, means nothing but we cannot access these memory locations as a bits. Similarly, the memory location from 30H to 7FH are also byte addressable, but 20H to 2FH we can access as a bits, that is from the memory location bits 00H to 7FH, means each bit can be accessed. For example, if you want to check what is there in this bit, or if you want to set the particular memory locations, or if you want to clear the particular memory location, we can do using the bit manipulation instruction. So along with this 128 bytes of RAM, other 128 bytes of RAM is allocated for the special function registers like accumulator, program status word, and the IO ports of the 8051 all comes under the special function registers. And among these special function registers, few are bit addressable and few are byte addressable. So whichever is the bit addressable, we can access those as a can access those things using this bit manipulation instruction, right? And here please note that here, as I said earlier, the bit manipulation instruction uses a direct addressing mode. In case of the special function register, we have an option. We can use directly these names as in the instructions, or the address of these instructions. Okay, right? So please go through this architecture, because to use this bit manipulation instruction, we must having the idea of which are the bit addressable memory location and which are byte addressable memory locations. And also that earlier we have discussed the data transfer instruction, logical instructions, and the arithmetic instructions. So in that set, many of the instructions are used on bytes, not the bits, right? See now, first we'll see clear, that is CLR bit. See, one more thing about the best thing in the assembly level language is that by looking at the instruction, we can tell that what that instruction does, right? That is CLR, means it is nothing but clear. It is nothing but clear bit, right? So this bit represents it can be a carry flag, or it can be a port, or it can be accumulator, or it can be a program status word. Means whichever is the bit addressable location is there, along with that we can use this instruction, right? See, for example, now if you see clear C. So what does it does is it clears the content of the carry flag. Okay. Next we have clear P2.4 is nothing but port 2, and that is 4th bit of the port 2, right? And remember that here the bits are as in the port we read bits as D0 to D7. That is D0, D1, D2, D3, D4, D5, D6, D7, and this can be read as, that is, for example, if it is the port 2, if it is a D0 bit means it is P2.0. If it is D1 means then it is P2.1, right? Okay. If it is the 7th pin means it is P2.7. Is it clear? Means D7 pin of the port 2. And next is here it is clear accumulator dot 7. So accumulator again it is the 8-bit register, right? Accumulator is again it is the 8-bit which that is from D0 to D7. So when after execution of this instruction, this D7 bit will be 0. Correct? And next we have here clear PSW.3, and you all know that PSW is my program status word, right? In this one many flags we check in the program status word. Correct? No? Right? That is see, this is the program status word, that is the D0 is for the parity flag, D2 is for the overflow, D3 for the RS0, and D4 for the RS1, D5 is some user defined flag, D6 is AC, and D7 is carry flag, right? So here if I write the clear PSW dot 3 is nothing but after execution of this instruction, processor will set RS0 is 0. Clear? If I write it is PS4 means it will make RS1 as 0. If I write it as a PSW.7 means it will make a carry flag this bit as 0. Fine. Right. And next similarly we have set bit 6, right? So this is just the opposite function of the clear instruction. So what it does, it is it set the carry bit, or we can use those instructions to set the any bit addressable location of the RAM. Okay. So same way I have written here set bit PSW.4 is nothing but if we use set bit PSW.4 means the processor will set the RS1 as 1. Is it clear? Right? If it is PSW.3 means it will set the RS0 as 1. Right? So next similarly if you want to set any particular pin of the ports, that also we can do, that is set bit P1.2, right? So in the earlier I said that this bit manipulation instruction is worked with a direct address. So here we can use special function registers as your name, or we can use the address of those special function register. Okay. See, for example, we'll see now here. The port P0 assigned is from 80H to 87H, right? So now we can write, for example, if you want to set the first, that is 80, that is P0, C, correct? So what we can use, set bit P0, 0. Instead of this one, we can also use set bit 80H. So both the instruction does the same operation. But in case of this from 20H to 2FH location, we have to use the direct address. For example, if I want to set this memory location, that is 7, right? That is we have to use set bit 07H. Is it clear? 07H. So we have to use here direct address. Next is CPLC, something complement. See, it complements the carry flag. For example, if the carry flag maybe it sets 0 due to some operations, if you want to complement this carry flag, then we can use complement C. After this instruction, the carry flag will become 1. Is it clear? And similarly, this also, that is CPL bit, means this bit can be any particular pin of the port or any particular pin, bit of the special function registers, right? So next we have here, okay, before going this, explaining this one, we'll see some examples on using the clear and the set bit. Okay, so we'll take the example that, move accumulator to R7 of register bank 1. Is it clear? So now I think you might know that you have studied in the first module that by default the processor select the register bank 0. That is means PSW bits will be 0. Correct? So now we need to save accumulator, content of accumulator to R7 register of register bank 1. Correct? No? So how to select the register bank 1 means this RS0 should become 1 and RS1 should be 0 itself. Correct? No? If I do this one means register bank 1 will be select. So how to do this one now? Our RS1 is 0 itself, and for the register bank 1 also it must be 0. So no need to do anything for this RS1, just we need to set the RS0. So for that what we can do, set bit PSW dot 3 and then move PSW dot, move R7, comma X. Okay. So when we do this instruction, when we use this instruction, it will select the register bank 1 and then the accumulator content will be stored in R7. Okay. Now for example, again, move again this accumulator content to register R3 of register bank 2. So register bank 2 is nothing but RS1 should be 1 and RS0 should be 0. So right now RS0 is 1 and RS1 is 0. So now what we need to do now? I need RS0 should be 0. Correct? No? But this is having 1, so it should be 0. So what I can do? Clear PSW dot. So what does it will do? It will make RS0 bit as 0. Okay, right? And now RS1 actually is 0, but we need 1. So for that what we can use? Set bit PSW dot 4. So what it is will do? It will does RS1 to become 1. So now we can use move R3, comma A. Right? So now till here it is register bank 0 and after this instruction this is register bank 1. So like this we can make use of the clear and the set instruction, right? And this set and clear instruction are mainly mostly like in many cases we use in the timer programming that we will see in the module 3 and 4. Okay. So next instruction we have here is ANLC comma bit. So this ANL we have seen in the logical instructions part, means this will do the logical and. In the logical instruction part, we will use that to operate on the bytes, but in this case, we will be using to operate on the bits. So what this will do here, it will AND the carry flag with the bit of the any bit addressable location, and the result will be stored in the carry. Correct? So this is C, and this bit can be any. This is P2.2, or it can be any direct address. Okay. Only condition is this should be the bit addressable location of the 8051. Okay. Right. And similarly here we have ANLC comma slash bit. So slash bit means complement of the port. Okay. For example, now what is there here? It is we need C, and then here the port we have is P2.2, right? That is D0, D1, D2 pin of this. So that we need to complement. It will complement, and then it will do and then result will be stored in C. Okay, clear now, right? So next, similarly, we have the OR operation. Correct? We have the OR, means this does the logical OR between the carry bit and the complement of the bit or the bit. It is same in what we discussed for the AND operation. So what it is, it does OR operation between the carry and between P2.3 and this. So here we have a slash bit is nothing but complement of the P2. For example, P2.2 is having 0 while executing this instruction, right? So now when we use this instruction, here we have a 0, but we are going to do 1 with the carry flag, and the result will be stored in carry flag. Okay. Next here it is ORLC comma bit. It is same. This instruction will do the logical OR between the carry flag and between the P1.2, and finally the result will be stored in C. Okay. And next we have here move C comma bit. So in data transfer instruction we have seen many move instruction which works on the bytes, but this instruction will work on the bits, that is move C comma bit. So here carry flag means whatever the bit we are mentioning here, that we are moving into the carry flag. So both should be bits. Okay. And here it is vice versa, means whatever is there in the carry flag, we are moving that into the bit flag. So this bit, for example, we can say it is move bit means move P0, 6, C. So means content of C will be moved to the port pin, that is 6 pin of the port C. Okay. So next we have JC, JNC, JB, JNB and JTC. Okay. So whatever we have studied till now, right? So this will not change the control of processor. Okay. This will not change the control of processor, but this instruction will change the processor direction. Is it clear? Right? For example, now that is JC, and this relative, it is an address, means where it should go if the condition is satisfied. Right? See, the name is a jump if carry bit. Okay? That is jump if carry bit in the PSWO is set. Okay, that is in PSWO carry flag is actually it is D7 bit. So if this bit is set, then it should jump to the location whatever the relative address is mentioned. Is it clear? Right? And similarly we have here JNC, that is jump if the carry flag is not set. Means if the carry flag is 0, then jump to the particular location mentioned in this instruction. Otherwise, execute with the next instruction. Okay. So here now these two instructions are used to check the carry flag. So in this we have jump if bit. Means if the particular bit is set, then we should move to this relative address. See, it monitors the given bit and jump to the target address if the bit is set. Correct? The bit can be any bit addressable location of the RAM ports, registers of 8051. And one more thing, these instructions mainly used in the timer program. Right? It means, for example, we can say jump bit some program that is P2.2. Okay, fine, right? So next is JNB bit. Correct, no? That is JNB bit, comma, relative. It monitors the given bit and jump to the target address if the bit is low. This one just opposite to the JP. If the bit is not set, means if the particular bit is 0, then we need to move to the particular relative address. So the example you can see it is jump if no bit P2.3 link. Okay. So here JBC. So there is a difference between this JBC and JB. So in this one, just it will check whether the bit is set or not. But what it does here, it will check the bit is set. If the bit is set and we will going to relative address, it will clear that particular bit. That is jump if the bit is set and also clears the bit. So we can use here it is JBC accumulator dot 7 label. It will check the 7th bit of the D7 bit of the accumulator. If it is set, it will move to this label. Whatever the address will be given here, it will go there, and also it will clear the D7th bit of the accumulator. Okay. Now we'll see one example. How to use this JC, okay, or the JS. Right?